Calculating average atomic mass. The average atomic mass is the average of all of the naturally occurring isotopes of the element. Think about it as averaging your class grades to get your final grade for the quarter. Let's use this example of your grades in the class and the percentage that each is worth to get your final grade. So, for attendance, you have 100%, but that 100% is only worth 10% of your final grade. Tests, you've averaged an 85. Homeworks, you've averaged a 75. And projects, you've averaged a 70. And each of those is worth 30% of your final grade. Well, when it comes time to calculate your final grade, we need to remember a couple of things. First, let's put down each percentage that you got. Then we're going to times that by how much it's worth in your final grade. Well, when we multiply by a percentage, we have to remember to move the decimal point. So for your attendance, you were there for everything, so you have 100% attendance, but it's 10% of your grade. So we have to move that 10% decimal point 2 places to the left and multiply it by 100. And here's what you get for each section. Attendance is 10%. Tests are 25.5%. Homework is 22.5%. And projects are 21%. So your total grade is a 79. Well, it's the same thing for the average atomic mass. Here's an example for you to work on. Find the average mass of C12 and C13. Now, do this the same way we just did for your grade, but instead of the average percentage of the category, use the mass, and instead of the percentage of weight for the grade, use the percent abundance. Pause the video here and try it for yourself. So how'd you do? Using the formula from before, we know that the mass for C12 is 12 atomic units. And we know the percentage is 98.892%. Likewise, for carbon-13, we know the mass is 13.00335 units, and the percentage is 1.108%. Remember, when you're multiplying by a single-digit percent, you need to have a 0 before the first number in your decimal. As you can see, we get a total mass of 12.0111712 atomic units. But why is it that I had to cross off the last set of numbers? Well, this comes from scientific notation and from the significant figures. Whenever you're calculating something, you have to use whatever significant figures it is that you need. Well, in this case, we use the smallest number of significant figures in any of the original numbers. The smallest of these numbers comes from the 12.000 in the mass of carbon-12. So that has 5 significant figures. In the answer, we have to have 5 significant figures. And we do. 12.011 has 5 significant figures in it. So what have we learned? We've learned the average atomic mass is the mass of all the isotopes of an element averaged together. And we've learned how to calculate that atomic mass.